Welcome back to the Green Network Summit, part of our DSP Leaders coverage. And time now for our live Q&A show. I'm Guy Daniels, and this is the first of two Q&A shows. We don't have one tomorrow, but we do have another one on Thursday, which is the final day of the summit. Now, there's quite a storm raging outside the studio at the moment, but hopefully it won't disrupt today's show. If you have just watched our in-depth panel discussion that looked at how to ensure a sustainable evolution to the green network, then you may have a question or two. If so, send them in now using the Q&A form on the website. Well, let's now meet our guests who are here to help with all of your questions. And joining us live on the programme today are Terje Jensen, who is SVP Network and Cloud Technology Strategy at Telenor, Beth Cohen, SDN Network Product Strategy at Verizon Business Group, Mark Gilmore, Chief Technology Officer for Connectivitree Europe, Maria Lemmer, who is co-founder of Weaver Labs, Frances Haysom, Principal Analyst with Appledore Research, and Juan Triay, who is Manager and Network Architect at Docomo Eurolabs and also an ETSI NFE Rapporteur. Well, hello everyone. It's good to see you all. Let's get straight into our first audience question because we have had a lot of questions. So the first one concerns the radio access network, and the question is, why is the RAN responsible for 70% of telco CO2 emissions, and are there any effective methods or tools available to measure RAN emissions? I looked this one up actually, and it might even be 80% of in-use emissions. It's certainly a large number. Terje, perhaps we could start with you. Any insight as to why the RAN is such a large contributor?
Yeah, thanks, Guy. It's an excellent question, of course, and it's one of the key things we have to address as an operator, of course. So just to be very precise, when I refer to 70% earlier, it's actually 70% is referring to the energy consumption. So it's not really the CO2 or the climate footprint. So in order to translate between the energy consumption and the CO2 footprint, you have to consider the energy source. Is it a clean source or a source which is using other kind of means to produce the energy? So very precise on. There's a slight difference between the energy consumption and the climate footprint. But if you go into the number 70%, I think it's fair to say that it basically is composed of three factors. So the first one is the simple fact that in a country, for example, typically there are several tens of thousands of radio units. So the sheer amount of equipment actually is driving, of course, the percentage or split of the energy consumption there. For example, compared to a core network, which typically are located maybe in less than 10 sites in a country. So that's one of the factors, the sheer amount of units. Then the second factor is to consider is that the radio equipment is also consisting of a transmitter, which again is having a power amplifier. And a power amplifier typically consumes roughly 60% of the total energy from the radio part, so from the RAN equipment part of it. So just the task of amplifying and emitting energy out on the air is kind of one of the key sources why the RAN part is consuming a lot of energy. Then if you also consider the CO2 emissions as well, it's again back to the what kind of energy source do we have at the site, and many of these RAN sites are placed off grid, so it might be a challenge actually to get connected to electrical grid, for example, meaning that you are leaning on other kind of energy sources, including, for example, diesel generators. And of course, as soon as you are using a diesel generator, the CO2 footprint is galloping in a way, or driving these numbers very, very high in that sense. So I think again, it's the RAN, the share of the energy consumption comes from the number of units that they have power amplifiers, and also that they are located a bit off grid, quite many of the sites there. Then I think the second part of it, I'm quite sure there will be other panelists also addressing it, but there are models on and looking into, benchmark and the work going on, for example, in ETSI and ITU and GSMA and as well as others, both when it comes to a lab or a test bench versus a setup, and also in how to measure that in a live network. So there are quite many models, and then of course also tools on the so we can probably happy to go into that, but I'm sure that there are other panelists who want to share more on the tools and the models there.
Great. Well, thanks very much, Terje, and thanks for us also, pointing out this relationship between energy usage, power usage and consumption, and also CO2 emissions. They aren't completely separate there. Joanne, let's come across to you next for your take on this as to why emissions are so high in the RAN.
Yeah, very good explanation and answer already given. So I cannot actually provide that many more details. It is, it's also our case that there is not this direct translation of CO emissions and power consumption. But when it comes to power consumption, roughly speaking, we also have around those same figures. And as it was already very well explained, basically the volume is one of the major factors that incur on this huge amount of percentage of power consumption. Now, coming to the second part of the question, whether there are efficient tools, I think that we have already discussed in the past that there are already new technologies being developed in certain cloud environments and also in environments of generic COTS infrastructure. So it's much more efficient to also collect power data. And on top of that, if I speak for the case of Docomo, there are no actually good tools that we can leverage at network scale. I mean, from an overview of the whole network. In that case, we have to typically develop our own tools. And this is also the case for what we've done in our company, that we have our name Docomo Energy Management System platform that is not only able to actually collect data about the power consumption of the base stations and the RAN, but also to actually even count and compute the power energy that is generated, because we do have also some other sources of energy that are also supplying energy to the RAN network. So we are also able to collect data and basically process it all together to deliver the best optimization of the network in the end. That's, I would say, basically the outcome in this case, that we need to complement all the tools that are developed in the infrastructure level with our own systems for processing larger scale energy consumption in our network.
That's very interesting, Joanne. Thanks so much for that, and explain to us what you're doing yourselves and also how that integrates with your other needs. Beth, let's come across to you for your thoughts.
Yeah. So I think, as Terje pointed out, the RAN is a distributed system, which means that unlike in a data center, you're not, you're dependent upon, whatever random power source there is around, which, a customer site may be, maybe the local power or a diesel generator or whatever. So that's obviously going to affect the efficiency. But I think the only way to really address it is to really look at the hardware and make the hardware more efficient and to cut the power consumption. That's something that it needs to go down to the chipset, which is, it's outside of the hands of the telcos. But I think that that's an important a way that we can reduce the power consumption and the obviously the sustainability footprint as well. So I am hoping that in going forward that there'll be more attention paid to improving the efficiency of the hardware itself. I do want to touch on the use of AI a little bit here. I know we're going to be talking about it a little more. AI itself uses power because there's a lot of it generates a lot of just running it generates a lot of power consumption. However, it can be used for modeling purposes, which can help. So you can build a model and not do it continuously, and then use it to build a more efficient model of the RAN network. So those things are none of them are being done now, but I think that is a future direction to cut the consumption. It's never going to be it's always going to be the largest piece of consumption because, as Thierry pointed out, it's the biggest piece of the network. But we can be more efficient about it going forward.
Yeah, thanks so much, Beth. And as you say, it's, as you all said, it's scale, but small improvements will make a big overall difference. And you mentioned hardware improvements there and advances that we need to look at going forward. Maria, let me come over to you, because there's also software, and there's software-based tools that we're using now and we can develop and work on in the future.
Yeah, I mean, the fact that in Open RAN we have largely decoupled the hardware and the software in the RAN, it definitely helps to bring a lot of improvements in how we actually manage the workloads of the RAN itself. So with just the separation of the RU and the CU and the DU, and having a large part of the RAN running in commercial off-the-shelf equipment, it helps us a lot in being able to hook in monitoring tools and allow us to extract a lot of information from the power consumption of those components, adjust the workload of those components of the RAN as we go and as we need it and as the capacity is required. And more importantly, there is a new component, which is the RAN Intelligent Controller, which can be used to actuate on certain areas. So, for example, one thing that we are doing at Weaver Labs is we've integrated a energy monitoring tool that we can actually be constantly monitoring the power that it's consuming, the RU and the servers running the CU and the DU, and correlate that information with actual capacity that it's going through the network, and send instructions through the rigs so that we can switch on and off, or increase or decrease the capacity of those resources. So there is a lot of tooling that can come through the use of monitoring. And because now everything is software, it's not just a black box like it used to be before. There's tons of innovation that can come in the form of software platforms.
Great. Thanks very much, Maria, for those insights. And I've got a follow-up question here, which I'd like to bring Francis in on, related to power consumption. And the question is, how does the RAN compare to data centers in terms of energy use? And are there any other heavy power consumption elements within a telco's network? Francis?
Yeah, there's a lot of really good information actually on the internet. I don't want to claim any special knowledge here, but I think it's interesting to look at the numbers as to what that can mean in terms of some of the decisions we might want to make as telcos. The International Energy Agency, IEA, which is an intergovernmental organization, estimates for 2022 roughly that about between 260 and 360 terawatt hours are used by both networks globally and data centers. So roughly in the same kind of area. Now, if you apply the maths of roughly about the mobile networks are roughly about 2/3 of that cost, and we've already discussed the RAN being about 70% of that. It means that the RAN networks globally are using about half the energy of all the data centers globally. So that gives you a good indication of the scale of the problem in terms of energy within the RAN. But the other key thing is that whilst there's been huge growth in obviously data centers globally, and whilst they've increased what they're doing by about 550%, actually the power increase of data centers has only been about 6% in the same period. That's not the case. As you expand out the RAN network, you're not getting those kind of energy savings. There's some very valid reasons for that, which is that inherently it's distributed, it's localized. You don't get these huge savings that can be done, particularly with the hyperscale public cloud. I think in terms of measuring the solution, Maria already said, I think as we move much more to a software-based network, things like, for example, the Kepler initiative, the ability to monitor energy within the cloud by the CNCF, and also some of the tools like eBPF, which is the ability to embed processing within the kernel of the Linux, will give us a lot of tools in which we can actually develop measurements and control. But I think the important thing in terms of our ability to actually do that is not just simply being able to measure it, but to actually be able to do something about that. And there's two areas of that one of which is the exposure of control points that we can make energy decisions. But there's also an operational thing, which is that we need to be confident to make operational decisions, to move things around, to optimize things. And if we're already knowing some of the complexity to do with network slicing, for example, where it's quite difficult to actually coordinate and manage across the end-to-end picture. It's a similar sort of area of complexity that we need to be looking at in terms of energy management.
Great, thanks very much, Frances, especially for those figures at the start, and trying to put them into context. It's sometimes hard to contextualize these large, vast numbers. I'm coming across to Mark in a moment, but Joanne, let's come across to you first for additional comments.
On this one, actually the question is also about what other elements in the network contribute to the power consumption. So when I get information actually of power consumption or energy consumption in our network and emissions of CO2, I get actually the numbers disaggregated in two main parts. Actually, one is the mobile network and the other one is the data centers. So there are no additional numbers that are provided that can actually see the accurate data of what other parts of the network contribute to the power consumption. So my summary of the question and the answer is basically that these are the two main parts of contributing to power and energy consumption in our networks nowadays.
Great, thanks, Joanne. And Mark, I promised to come across to you, so let's get some comments and insights from you, Mark.
Off the back of those numbers that Frances gave, it shows the real opportunity within the data center space then to absolutely go for clean energy to be able to reduce down. There is the opportunity. Terje mentioned right at the beginning of this Q&A about how that's more difficult in the RAN environment, but in the data center space, it becomes really, it should be table stakes, and it is to the most part. When we're approaching data centers, it's very high on our agenda, asking them how their energy is sourced, because that becomes a key critical component of our Scope 2 emissions. I know we're talking a little bit about power consumption here, but the other thing that really affects the overall emissions or outputs, from a telco network is actually the people as well. So we should not neglect the impact that people have, as well as the technology, as well as the RAN and the core components, the data center components, but also people have an immense impact on emissions.
Good point to make there. Thanks very much, Mark. Let me bring in Terje and Beth, and Terje, let me start with you.
Yeah, no, I think just to come with some examples of numbers. So roughly 90% of the total Telenor energy consumption comes from the network domains. So that means that it's 10% coming out from the running offices and other kind of activities what we're doing. Then if you look into this 90%, we were collaborating with a group of operators just to, starting on comparing and discussing what we can do. So diving into this network domains, as I said, the RAN typically consumed something between 70 to 75% of that energy, and the remaining part of it. Then we looked into domain which were fully owned by the operators. And if you look into those domains, typically what you call a technical center consumes something around roughly 10%. If you translate the technical center, it would be like a data center in some languages. Mobile core, roughly between 10 to 15%. And the operations support system, something like 5 to 10%. So these were the other domains. But then it's important to remember that this was only the owned assets for most of the operators. So examples like what Francis mentioned, like public cloud, for example, is not covering the scope. Neither is the full transport network, which is also kind of a major component for consuming energy in many countries. Then it's also came across as quite obvious when you compare operators in, say, Northern Europe to some of the operators in Africa or in South Europe or in Latin America and Asia and so forth. There is a vast spend of split of this consumption, depending, for example, on the climate, what traffic volume you have, how many technologies you have, for example, how many sites do you have with 2G, 3G, 4G, and 5G? What is the demographics and also the geographical distribution and coverage patterns, for example. So there's a lot of factors to consider into when you're discussing percentages. So don't get lost in average numbers. It's very important to go into the assumptions and the details behind these numbers.
Really good points, and we focus on technology, just pure technology, but there's, as you said, there's also the geographic differences and the demographics make a huge difference to the actual percentages and numbers. Every telco, as we say, is different, a different use case. Beth, let's come across to you for your thoughts on this one.
So I want to pick up on some of the things that Mark and Thierry said, which is that you have to look at the bigger picture. Yes, our power consumption is mostly our RAN and our data centers. But on the other hand, every time we don't have a truck roll because we've virtualized something and we can reach it remotely, that reduces our carbon footprint, right? We're not running a truck. We're reducing our CO2 output. So you do have to think about it in the larger picture. And also, yes, the power consumption of our mobile networks and our networks in general has gone up. On the other hand, as we discovered during the last 4 years going through COVID, so many things have shifted. So people have realized, you don't have to go into the office every day. And again, that reduces the power consumption. It doesn't reduce the power consumption to the telco directly, but it reduces the overall power consumption, even though, so things have shifted around. And, as people work from home more, and that's not going away anytime soon, despite what, CEOs say, oh, we have to get back to the office. Hey, I know you've signed, some very long real estate contracts with to cover these buildings. But the fact is that, what? We can be just as effective working from home as coming into the office, and it reduces our carbon footprint. So it's a win-win all around.
Thanks very much, Beth. We love working from home. Absolutely. Let's move on to another topic. And it was mentioned earlier. And in fact, Beth, you mentioned this earlier. You brought up AI. And next question is focused around AI. And the question asks, AI requires huge computational capabilities and therefore adds to power requirements. So in order to achieve their energy efficiency targets and still be competitive by using AI, what do telcos need to do to balance this equation? This is something we touched on in the panel as well, but Beth, because you brought this up earlier, let's come back over to you and let you start us off with this one.
Well, first of all, AI is just starting, particularly around the network, and I call it intelligent networking rather than AI, in general. And yes, we can use AI and generative AI to be more intelligent about how our networks run, but we don't have to run it all the time. We could use it to model things and then take those learnings and put it and apply it in the network. So we can be, if you will, smarter about using our AI and still reduce our carbon footprint. I'll use an example of they've been using generative AI to look at new types of medicines, and they're not going to use the generative AI to create the medicines, but they're using it to, explore new possibilities for medicines. So I think that's the better way to do it for networks. Not do it continuously, because then you lose the advantage of running it if you're just soaking up all your efficiencies by running the generative AI. So, we're definitely going to have to work on that. And since AI is just new for networks, I envision that things are going to change over the next couple of years quite a bit.
Thanks very much, Beth. Well, let's go across to Mark and get your take from your perspective of the network, and how do telcos balance this need to implement more AI within the networks without necessarily ramping up their power budgets?
Thanks, Guy. I think this is an interesting question because it kind of hits at the pulse of what we tend to do in telco and within the whole hype of the next technology. That is, we get this technology and we want to apply it everywhere, irrespective of the consequence or the need, just because it's the latest and greatest technology. And we kind of get caught in that trap each time round, really, as an industry. And I think this question kind of points to the right sizing and right application of technology. I have no doubt that AI, intelligent networking, as Beth put it, that is going to have a huge benefit and allow our operators and the industry to remain to be competitive and keep moving in that direction. Absolutely, for sure. And actually, I think we will use AI. We're starting to use it, and particularly automation, for the optimization of resources. Going back to the point about if you can optimize those resources, then you are using them energy efficiently. So there's tools and mechanisms that we can develop to be able to use that and use some of the skill set and the technology coming out of the AI environment. I think it's about right sizing and making sure that the application of the technology is being used appropriately. We don't need a huge global language learning model to focus in on finite restricted parts of the network, for example, that are in a very focused environment that doesn't require a global language learning model, for example. So it's using the technology wisely, I think, will make a huge difference in that. And I think Beth pointed to it earlier on when talking about the use of digital twin, for example, for like test and trial environments. That's a particularly interesting area to look at, because not having to completely replicate with hardware and full software, if it can be encapsulated within software and run as a digital twin, for example, utilizing some of the machine learning technology and AI capability, then that has to be a win. And not having it on all the time. It doesn't need to be run in a 24/7 environment, in that sort of environment. So there's things that can be done, but it doesn't mean that just because AI is out there as the latest and greatest technology, that it has to be used in every circumstance, because otherwise it will just keep moving up the compute and power requirements and negate any of the advantages that we're taking in other areas.
Thanks, Mark. So as you and Beth have both indicated there, it's use when it's needed and where it's needed, not necessarily just go crazy with it. Let's get some more views on this, though. Maria, let's come across to you next.
Yeah, I'm probably going to come with the most futuristic view of this, and rather looking at it from an innovation perspective rather than just the practicality of the implementation nowadays. So we are part of a lot of, research projects and looking at where the next generations or the future network architectures are going to take us. And there is no doubt that the AI and knowledge-based networks are something that are happening right now in the design and requirements and shaping the next generation and the next standards. So it is no question it is going to happen. And that there is the ability to have this knowledge layer that assists orchestration and infrastructure at the same time through the use of different types of learning that doesn't have to be just generative AI. It can be based on machine learning and other type of modeling. And also the coordination between of all of these agent-based type of learning models that can influence the network and can help us orchestrate better the resources. That's for sure going to happen. And the reason why it's going to happen, it is because it helps us be more efficient. It helps us use our resources in a much more effective way. And this is all based on cloud at the end of the day, right? It's coming from the perspective that the network is going to be running in a cloud environment. It's going to be based on APIs where we are able to gather information, analyze that data, and actuate on that data. So the first and most important thing that needs to happen for it to be efficient and not just a waste of resources is to have an efficient way to capture, sanitize, and deliver the data with efficient tools, software tools that allow to do that. And for that, we need vendors and software manufacturers to contribute to that with standardized data models and contribute with open APIs so that we can actually create efficient knowledge layers that can help assist in the efficiency. But as I said, as part of all of the research work that, for example, at Weaver Labs, we're part of the Reason project, which is funded by the UK government. No question, it's going to happen. And there are tons of leading vendors that are leading research on AI for networks that ultimately are going to be implemented in their product.
Great. Thanks, Maria. It's always good to know that the research work is being done now that will eventually work its way through, or hopefully quickly work its way through and eventually get into commercial production for the telcos. Terje, let's come across to you next.
Just a short follow-up, I think, what Beth and Mark was addressing. So I think it's important to remember that, AI is not one thing. You can have fairly simple AI models with fairly limited also data sources as well. Then of course you have the more advanced AI models which require extensive amount of training and maybe a lot of data sources as well. And then of course you have generative AI. So I think it's important in this discussion that AI is not one thing, but it could be multiple things. And I think it's very, very important what Mark was raising. You have to choose the right model and the right way to approach it according to what you want to achieve. So say, for example, just to mention two examples, we have applied AI for switching off radio equipment when there is low traffic demand, for example, typically switching off 3G base stations and 5G base stations if there's no need, for example, and also switching off the high spectrum transmitters and keeping the low spectrum transmitters on just to have a basic service level. That doesn't require a lot of training, doesn't require a lot of data either, and you can get roughly 10 to 15% energy savings out of the radio equipment. fairly easy. So that's kind of not requiring a lot of effort to do. Then similar a case we had with when is the optimal time of replacing batteries, for example. Again, it's fairly a simple model. You don't require a lot of training, basically, but you have to get the data, of course, from each of the batteries, which are on different sites. So there are a number of AI cases which are fairly simple in model and also doesn't require a lot of data. Then I think back to what Maria, I think I fully support what she's saying, that if you have to do large language models and develop that and train those and run generative AI according to that, I think it's very good to collaborate and join forces. What we also see that some of the operators are doing, for example, shaping up alliances, and there are also a number of other initiatives across the industries and in different other industries and different countries. So teaming up, of course, and then sharing the benefit of that would be one key input to balance this equation. So I think there are a number of things you can do. And just remember, AI is not one thing. There are multiple things there.
Yeah, absolutely, Terry. It's a nice short acronym, AI, but it covers a multitude of different methods and technologies. Francis, let's close out this question with comments from you.
Yeah, just a couple of small points, and it really builds on the other comments. I think the really important thing about using AI is we need to recognize it's somewhat a behavioral change as well. We will save energy if we're prepared to use the insight that AI gives us. Whether if we choose to use AI as a means of telling us when we can switch off energy but don't use it, then that's wasted energy in the AI engine. We need to be prepared to use the insight of AI. And Beth raised it earlier, which is the fact we need to balance the insight and the benefits of something like AI, better field force, no field force, those energy equations. We need to be doing the accounting in terms of where we're saving energy and where we're gaining energy, where we're deploying energy.
Yeah, thank you very much for those comments, Francis. And thanks, everyone, for your answers to that question. Okay, well, it's time now to check in on our audience poll for the Green Network Summit. And the question we are asking you this week is, how can telcos most effectively reduce their energy consumption levels? And hopefully you can see the real-time votes. Well, there you go. Real-time votes have appeared as I've been speaking there behind me. Early days on the poll, but probably no surprise that turn to the vendors to do the hard work. Source more power efficient technology from vendors is performing very strongly. Now, if you've yet to vote, then please do so, because we're going to take a final look at the voting and close it during Thursday's live Q&A show. Okay, we still have time for a couple more questions if we are quick and we can speed through them. Here's a great one in on innovation, which was one of our poll answer choices. And the question is, what are the specific sustainability pains or gains that require new inventions or technology innovations? And Mark, let me come across to you for first responses for this one.
Thank you, Guy. The one that really stands out for me is the work towards 0 bytes, 0 watts. I'm very keen on that initiative. Where the area that I work in, which is more on the backbone element of a network across international borders, for example, we need to pull some of that trickle down technology advances that we're getting that are being implemented in the RAN and in higher OSI layer up the stack there in terms of network equipment, and try and bring that down into the foundations of the backbone network as well, so that we can implement and start to really turn the energy consumption down, not just on a per watt per bit basis, but also in a very real way in terms of consumption. That's an area that I really want to see more development work on, which is kind of a development of I think Beth mentioned it earlier about the continued development in the chipset, in the hardware vendors. It's particularly important in my area in that. But the other area that I think requires innovation, not just in the technology, and I mentioned this in the panel session earlier, but is also about the approach that we take from a business model, and from a shared approach or operational approach across the industry. And that is equally as important in terms of the innovations and invention that we need to take. So not just the technology part of that, but also looking at it from a commercial and business model approach, shared infrastructure, as I mentioned in the panel earlier. Those sorts of things start to become really critical to the overall reduction of power consumption across the industry, so that then we can then start to look at how we really deal with scope 3, for example, across the industry and across the complete supply chain. And one final one from me is just looking at the overall energy efficiency methods into actually coding, into the software development that goes on. And I know there's some work starting to develop in that area to produce highly efficient code, so that in the world of disaggregated software and hardware, we're not putting all this effort into increasing the energy efficiency in the hardware, and then putting sloppy code on top of it, which then increases the overall power consumption across the board. Those are just a few areas that sit with me.
Good, and good areas they are too, Mark. Thanks very much for highlighting those. Yeah, very important areas. So, Joan, let's come across to you next for technology areas or innovations that you feel that we need to work on.
Yeah, I will also relate this question very much with the first one that was made today in the panel. What are the biggest contributors of power consumption or CO2 emissions? And if we consider the case of the radio and the data centers, it is also where we can actually get most of our gains, just by applying basic principles. Like, for instance, in the case of the radio network, just improving the development of the functions and implementing some power-saving functionality into the base stations. Those, if used wisely, can actually provide huge gains in terms of power consumption. And even if it is a trivial kind of idea or innovation, it is already delivering a very good output. Another one is, for example, related to the case of the data centers. As we know, one of the major contributors of power consumption in the data centers is about the cooling. So with initiatives like providing liquid-cooled equipment into the data center, like, for example, we have in our initiatives also at Docomo, we can also provide a huge gain in reducing the power consumption. And even though I just focus, for example, in these two concrete aspects, because I relate them also to our major contributors of power consumption, I also fully agree with what Beth also mentioned before, that of course there are many different kind of actions that can be done, just beyond of identifying a couple of them. Like, for example, promoting more home office, or promoting more automation, remote operations of our network. Also promoting the uses of more renewable energies in all kind of power sourcing, like in our buildings, in our vehicles, when we send some operator to the base station to do some maintenance of the equipment. So yeah, there are many different actions, but probably where we can actually gain the most is also focusing on those parts that we know that are the most contributing to the power consumption.
Yeah, you said it nicely there. There's an awful lot we can do. It's maybe focusing on where we need to focus first and put our efforts initially. Thanks very much, Joan. Francis, let's come across to you next. Then I'll go to Terry. But Francis first.
Yeah, I almost I think the technology is a given. I think the major innate technology enabler for innovation in this area is going to be openness. A lot of what we want to be able to do is about being able to get open measurement, detailed measurement, things that are not obscured necessarily by the traditional telco stacks. That ability to see the data, see how energy is being used is an important enabler, but also equally the ability to be able to, as I mentioned before, the ability to actually then take action and make changes on that one. And the second thing I'd sort of build into that one is I think as an industry, we're very good at seeing, look, this component of the RAN is using this amount of energy, or this component of the RAN is using this amount of energy. We need to be thinking a lot more about the sort of whole system accounting. For example, we may want to make policy changes as to how we move loads around, how we shape the network on the basis of the whole network, and the ability to bring up the energy equation as a part of that policy is an important enabler. And I think the third area is, dare I say it, regulation innovation as well. A lot of what you will want to do, the ability to increase better energy usage, better usage of compute resources, etc., is about being able to share, being able to get multi-tenancy, being able to get optimize your operational cost on that one. And we will need to look at this area of how do we balance the competition element versus the ability to save energy in that area. So I think there's an area there for innovation, just in terms of the regulatory approach.
Yeah, thanks very much, Francis. There's a number of CEOs of leading telcos who are also calling for regulatory innovation at the moment, and have been for some time. Good luck. I think this is going to be our last question today, because we are running out of time. So I want to make sure that everyone has a chance to respond to this one. Terry, let's come across to you for your thoughts.
Yeah, thanks, Guy. Just coming back to, I think, what Beth was mentioning earlier in the session, which is very fundamental, of course, that let's not forget about the hardware. And there is a need for chipset development, for example, moving from 7 nanometers to 5 nanometers and continue that, resulting in higher capacity and also higher energy efficiency, of course. Then, of course, the ability to dynamically control these processing units, for example, with lower power states, slower clocking rate, and those kind of things, for example. So, which is also important to master in order to control the hardware part of it. Then I think what Mark was saying, I fully agree on this strive towards 0 bits, 0 watts. I think it's quite fundamental. And in my mind, to do that, it's also good to close the loop between what the network can enable and what is the true need of the customers or the applications. So closing the loop between the applications and the network, I think, and exchanging that information about what you really need, and then keep on the network or keep the lights on the side on the network side to match the needs what they are looking for. Otherwise, we tend to keep the network always on, where there's still maybe not a true demand for these services. So be taking more risk, I guess, on the business side. I think what we also discussed in the panel is quite key to understand to what are the customers and applications really asking for when it comes to network and connectivity services. Then I think it's also just diving into a particular area. I think we see that the massive MIMO is deployed, in particular triggered by 5G. So to emit energy, only to the active interactions of active users, so you can avoid sending energy in all directions and rather focus the energy to those users, and then of course support them with the requested connectivity quality of what they're asking for. And this needs to be controlled in a three-dimensional pattern, as you have also the altitude to consider in a high-rise building, for example. So there are a number of things, I think, spanning across both the hardware and the closing the network and the applications, and also a number of solutions, how we see that. Then we also see, which is probably not an innovation, but simply shifting the traffic to the newest technologies. moving traffic from, for example, from 3G to 5G has a fundamental effect of quite important effect of the energy consumption. So let's not forget about those easy, quick wins as well into these calculations.
Absolutely. Thanks very much, Terje. And Beth, I'm going to come across to you, but I'm also going to add to this question. This question is all about innovations and new technology initiatives, but there was another question that we received in just before we started the show, and someone asking about solid oxide or hydrogen fuel cells and whether or not we'll see those used in our telco infrastructure. So let me throw that into the innovation and technology invention mix as well.
So it's hard to top what everybody else said, but fuel cells. So I will share an anecdote. My father wrote his PhD thesis on the topic of fuel cells for cars, and that was in 1968. Well, last time I checked, we still don't have fuel cells working for cars, and the reason is because A, they're dangerous, and B, we don't have the infrastructure to really support them. So, as far as we've gotten is buses have been using, compressed natural gas to a certain extent, although recently there's been a move toward electric buses, which, makes a whole lot more sense. And of course, you're much more able to control your power source. When you switch to electrical, you can use solar, you can use wind energy, you can use sustainable energies sources. So from the telco perspective, we have to do everything to really innovate, to get the energy efficiency that we're looking for and reduce our footprint. And and that's okay. To innovate, incrementally is okay. And of course, as I mentioned earlier, and as a number of other people mentioned, hardware is where you're going to get the biggest bang for your buck, but that's also the hardest to do because it has the longest lead time.
Absolutely. Yeah. Thanks, Beth. We do expect some more hardware news this year, or we hope so, and we'll be following that with a lot of interest. I'm going to come to Maria in a second, but I think Francis just wanted to come in quickly, and then we'll come across to Maria to close things out. So, Francis, did you want to just pick up on what Beth was saying there?
And Beth sort of hinted at it. I think the big thing about any of these technologies is not simply about the technology, it's about the ecosystem to be able to deliver it. If you look at things like electric vehicles, for example, it's not simply the fact that we have lithium-ion batteries, it's the infrastructure of charging, the whole ability to produce cars and engineer cars that is part of that one. So any of these technologies may or may not be capable of supporting the network. But it's their success is down to the ecosystem that comes with it, and we're kind of seeing this in more mainstream technologies already. Things like solar and wind, for example. Only a few weeks ago, ZTE, for example, are announcing major initiatives in terms of the building in of solar and wind technology into their deployments, like particularly for remote and global south territories as well. So I think, but again, that's happened because there is the ecosystem for solar, for wind, etc., that is now there and can be deployed at scale.
Yeah, the infrastructure to do it. Thanks very much, Francis. And just by the by, I was looking at a video today from about 15 years ago that featured a Motorola handset with solar panels all along the back of the handset. I don't think that caught on. Maria, let's come across to you to close out our Q&A for today.
Sure. I mean, I love questions about innovation, so why not? I just really want to get into one aspect that I think is where we should pay a lot of attention, because it's an aspect of opportunity, which is the code and the actual software that we are building. There is a lot regarding openness as well, that I fundamentally agree that there is a lot of innovation, and the software tools that we use are highly inefficient. And the fact that the entire network is programmed, regardless if it's the same as, if we are going to do a highly stationary private network, or if it is going to be a public network that is going to be handling millions of users, it is exactly the same code base. We need to move more onto service-based architectures. We need to move more using efficient tools such as messaging systems that connect different microservices and architect the software in a way that it is a lot more efficient. What we see nowadays doing Open RAN deployments is that we have a one-to-one mapping between CUs and DUs, and that is very inefficient. We can definitely use multiple processes to have one CU towards many DUs mapping, for example, and leverage all of that innovation that has happened in standards, creating those splits, and actually do that from a code-based perspective. Because one thing that we see a lot is that standards evolve in a way where it's like it allows vendors to develop a lot of more innovative products, but then because we create new versions of the same product as more an incremental approach and not so much disruptive, we don't start from scratch, and that is actually quite bit of a problem when we are actually looking at diverse applications of networks. So yeah, I think there are a lot of areas of innovation, because telecoms obviously covers a large part of the supply chain, from moving people to hardware to, power amplifiers or software. But this area, I think it's something that we can pay a lot of attention, and it also can provide long-term benefits, not only from an energy perspective, but also from an efficiency perspective and cost benefit.
Yeah, absolutely. Thanks very much, Maria. Well, we are out of time now. Thank you so much to all of our guests who joined us for this live program. Do remember to send in your questions for Thursday's live Q&A show as soon as you can. Don't leave it too late. And please take part in the poll. There's still plenty of time for you to have your say. Here's the agenda for tomorrow, day 2 of the summit, and we have a panel discussion for you on leveraging cloud native for network sustainability. Plus, we offer you a practical guide to energy efficiency for telcos. Until then, thanks for watching and goodbye.